ran into him walking out of the school.
Yeah, I know. It's because his brother's sick, so he thinks he's sick too. That's just
He said he had chills. He looked sick.
It's a mind virus.
It's a mind virus. Okay, so on Friday, we reviewed implicit. Stop talking, Mason. On Friday, we reviewed implicit differentiation, and we talked about that we can find out if something is increasing or decreasing. I don't know what this is. Is it increasing or decreasing by just plugging in the X or Y? Because this is negative. This thing I made up was decreasing at this place because the derivative is negative. Therefore, the original is decreasing. Okay, so what we are going to do, I think we started this, right? How'd you start this? It says, consider this guy. Oh, I know. I remember doing this. At the point 1, 1/2, negative 1, 1/2, is this increasing or decreasing? Okay, so you gotta do the derivative. It's implicit. What's the derivative of this first piece?
We do this on this piece of paper, right?
Yeah. Yep. 9x squared. The derivative of 3 is nothing. A little bit of problems remembering the derivative of natural log. The derivative of natural log is what? 1 over the x thing. So 1 over 4y squared. But chain rule says multiply times the derivative of the thing inside parentheses. So it's 8y y prime. Because y prime? Because you're doing this implicitly. Now, the thing that I said to some of you is before you go solving, if it was me, I would reduce this. This simplifies. You've got 8y prime over 4y squared. What does that simplify to? Yeah, this is 2. The y cancels, and it's just y prime. So this is 9x squared equals 2y prime, right, over y. Okay, now it's super easy to solve for y prime. How are you going to do that? Yep. You're going to multiply by y, and then you're going to divide by 2, which I'm not going to write that all out. So it's y prime equals 9x squared y over 2. Now, at that coordinate point, please tell me, is that increasing or decreasing?
And then is this where we do that stuff we just did? Or do we have to make a...
No, you don't have to do that.
Oh, can we graph?
No.
I think it's
Plug it in. What?
It's increasing.
It's increasing. Alex?
The third part, I don't understand why you multiply by y.
Because this is 9x squared equals 2y prime over y. So you got to multiply by y because it's on the bottom. It can't be there. So listen, all you're doing is plugging this in. Positive or negative? Positive. This is positive. So therefore, is the curve increasing or decreasing? It's increasing. And why is it increasing? Because you would have to say y on the AP test, because y prime is positive at that point, at negative 1, 1/2. Okay, that's it. All we did, just in case you are not paying attention, we plugged in the negative 1 and the 1/2. You don't even need to know what that equals, as long as you know that it's positive. This is squared. The negative's going to go away. Times the 1/2 divided by 2. That's all positive. Done. Okay. You plug that into the prime thing because that's what's going to tell you if it's increasing or decreasing. Okay. We'll go back to that first one, or back to the second one, but I want us to do this one. Why don't you try number 1? So same question. Is the curve increasing or decreasing? Number 1.
So is this topic just not in the book? Or?
It's not in the book.
How much do these books cost? Today,
$125, $150, somewhere in there. If there's a constant on the bottom, this is 1/2 x squared, right? Because dividing by 2 is the same as multiplying by 1/2.
Okay.
And that's way easier to just pull them out and make them a constant.
Yeah, that's really nice.
Is this?
You're waiting for
Okay.
Oh, you're not increasing.
Instead of
I got decreased.
Yep, you're done.
yes.
It's negative.
What amounts are you doing the quotient rule for, kid? Tell me.
Yeah.
Alex, why are you making life so hard? You guys do not ever do the quotient rule if there is a constant on the bottom. For heaven's sakes, people. Dividing by 1/2, dividing by 2 is the same as multiplying by 1/2. It does, but it's terrible. Because then Alex asked me, what do I do here? Yeah, don't do that. Okay, what's the derivative of this is 2x minus the 2 and the 1/2 cancel. So it's going to be y prime equals 0. Super easy derivative. But you guys, number on the bottom, don't use the quotient rule. Although, Alex, I applaud you for at least using the quotient rule and not doing the derivative of the top and bottom separately. So there is that. I would add this over, so you have y prime, and so y prime is 2x over y. That's your derivative. So at the point -1, 2, is this is the curve increasing or decreasing?
Decrease.
It's decreasing. Why?
Because when you put the numbers in, it's a negative.
Okay, so
Because y prime is negative at the point.
y prime is negative at that point, -1, 2. So if you were doing this on the AP test, you're like, hey, because y prime is negative, it would not give you that point because you did not be specific about where. Okay, so gonna bust your chops a little bit on that.
Do a whole bunch of people do that on the online assignment?
I don't know. I'm great at it.
Two.
Yes,
I heard the curve is decreasing at.
David, did you not already ask me this question?
No, 'cause I don't know if you like read.
I did read it.
In that order.
It's fine. It's fine. Because you referenced the point. You said at that point. Yes. So the order of it doesn't matter as long as you're referencing the point. Okay, same question for number 3, please. Okay, same question for number 3. We're talking increasing and decreasing.
Oh, Miss Douglas,
Oh, yes.
I have a question. I just to jog my memory. Okay.
Is this a plus or minus thing?
Yes. Because of the -2x. Yep.
Grody. It's positive.
So, then where do you put the numbers?
You don't have to, no.
Did you also get y prime equals 1?
Hey bro, what if people weren't done yet? You just split it wherever you want.
Nah, I think we're wrong.
I don't think it equals 1, I think it's -1.
Hey, David, that's a stupid thought.
I think it's -1.
Hey, David. Stop talking
Am I?
now. Yeah.
Yeah, go look at it.
Go look at this. Go look at
Go look at his work.
Look at my work. Where am I?
Genius.
Because yeah, look at the genius at work.
Okay, so y prime does equal 1.
No, I'm wrong.
Y prime does equal 1. I don't think that I made a mistake. So,
Wait, can you just double check?
Are you sure?
I think you need to check the genius.
I think you need to check. I think
Does
that's
that
the
just
numbers.
like the whole
I
time around
can't.
that?
exactly.
Look on those, you see there's two negatives right there.
Thank
That's
you.
more than one negative.
That's
so-
correct. Thank you. So, what does this tell you about at the point -1, -2?
So yeah, this is the flat line.
It's positive.
Right?
That's its slope, but it's positive, isn't it?
Yeah.
So it's concave, or so it's increasing. That means it's always increasing.
So do I not have to mention the point? Can I say increasing all the
I
time?
would say because if I was going to justify this, I would say because y prime is a constant positive, this graph is always increasing.
So it's like this line. It's linear. Yeah. Or is it not? Oh,
That's its derivative, though. Its derivative is 1, so yes, I would guess that the original is linear.
I'm right up to this point. We have the same.
No, I think it's just like the slope is the same.
That's why I have to-
Right, but it's a flat slope.
Same for the same.
Yeah.
Alex, what's your question?
It's the same as the-
The reasoning would be because this y, you can use the same reasoning. You can absolutely use the same reasoning if you don't want to have to think any deeper. You could say, hey, at the point -1, -2, this is positive, so therefore this is increasing. It's always positive, but they didn't ask you that. Okay, now this guy here relates to what we were doing on our warm up. So this business here, what's dy dx is another way to write what? Right. So y prime is y sine x. So we already have y prime. So the question, yes?
So if this was the AP test, would we have to first write dy dx
No,
equals?
no.
No, they don't care. I
No.
can just change it immediately.
Okay, so the question is determine if f has a relative minimum, a relative maximum, or neither at the given point. So there's our coordinate point. There's our coordinate point. So what things have to be true if it's going to have a minimum or a maximum? What has to be true of the derivative if it's going to be a minimum or a maximum? So it has to be 0. So the first thing I would check is to see if this is equal to 0 before I did anything else. Because if it's not 0, I'm done. I know it's neither, right? Because if it's a maximum or a minimum, the derivative has to equal 0. So just plug that in. So we've got, what's the x value, by the way? Yeah, so this is 2 pi comma 1. Listen, people, if you can't remember how to graph the graph of sine, what's sine of 2 pi? 0. So 0 times 1. So it is 0. So we know it's the derivative is 0. So this is that second derivative test I was talking about. There's no sign chart making on this. Okay. Well, what you can do is take the second derivative and we can decide if this is going to be positive or negative or neither. Okay. So please do the derivative of this guy. Yep. Oh, yep.
Because it's already in the prime.
Because it's already in the prime. So you only have to do one derivative, but because you started with a derivative, it's actually the second derivative.
How could you end up with multiplication like that? Would stuff have to cancel for it to come out the way the first one came out? Or am I crazy?
Stuff would have to cancel. No, you're not crazy. I mean, you might be, but not in this aspect.
Am I taking crazy pills?
That's bad.
Oh, I forgot what the product.
I think that we could really do that.
You guys
Was like 30.
No,
Okay.
I forget the product, I just forgot to look around.
Now,
But
here's something that is important that we talked about. We talked about first semester. Okay? We talked about first semester. You cannot have a y prime in your second derivative, so you got to replace this. So y double prime is equal to y sine x, which you can write as sine squared, but it doesn't matter because we're going to plug in numbers anyway. Okay, so again, make sure you're listening to me because I don't want to repeat this again. You cannot have y prime in your y double prime, and so that's why I have to replace this with the original y prime. So it's all in terms of x's and y's. Now plug in your 2 pi and your 1 and see what you get.
So they probably wouldn't give us a calculator on this one, right?
Nope, not at all.
I don't like having to remember all these things.
Maybe it's negative though, David. You never know.
David's law, if it's right, then that's.
Oh, wait, two.
We do it 1 pi.
That's how I'm gonna get my, that's how I'm gonna get my. Because I'm gonna get David's law, it's right as well.
Okay, so here's my cosine graph. So I know cosine of 2 pi is 1. Y is 1, y is 1, sine of 2 pi is 0. So this whole mess comes out to be 1. Now, this is positive. So when we put those pieces together, if my second derivative is positive, that means concave up. So, is this a minimum, a maximum, or neither? It's a minimum. This is a minimum at the point 2 pi 1 because y prime equals 0 and y double prime is positive.
So we can say at the point 2 pi 0, even though we're only given the equation for it.
You're given the point though.
Well, we wrote that down.
It's here.
Yeah, I know, but it's in its equation.
That's oh, it's in its function form. Yes, you can use this notation. That's what you're asking me about the notation.
Say that y prime equals 0 in your.
Yes, because if it's not 0, all that tells us is that it's concave up. It has to be both of those that are true in order for it to be a minimum. The derivative has to be 0 and the second derivative is positive. That's something, you guys, that's called the second derivative test. It should be in your notes from this semester.
So even though we're not given the second derivative, we can still use it
Because you created it, right? Because you created it and it comes directly from that, then yes. Okay, it's more a matter of, Remington, it's more a matter of you can't use it if, like, it's a graph, right? Like, they're not, but if you are calculating something and you're like, hey, here this is, then yeah, you use that.
So if they give us a graph for f prime, we can't like talk about f double prime because we don't know what f double prime is.
Correct. Nor can you talk about f. But because we got it, we have a factual thing that's f prime, f double, or y double prime here, then you can use it.
If it's asking about f based on an f prime graph, then you can refer to it, right?
Ask, yeah. If it's asking about f, yes. Okay. Oh, this one, actually, we're skipping 3. We are going to do 2, though. Okay. Just a second. I got to make sure I'm leaving us some homework. Nope, we're not doing that one.
We're not doing 2?
You're going to do 2.
That's some worker right now.
No.
What
Just a second.
At some point.
Okay, I lied. We're gonna do number 2. Okay. I know I'm being very wishy-washy. Okay, so we are going to do number 2. So the question gives us this equation and asks us at this point, is this concave up or concave down? So concave up or concave down means I have to use what? Second derivative. This is a sad one though, because I don't have the first, not the first derivative. This is the original. Grody. So first derivative first, please. Nope, me neither. Okay, first derivative first. It's not terrible. In the scheme of first derivatives, it's not terrible.
I just don't like that they put a Y there.
So what is that?
Here?
Yeah, it makes me feel they have two these.
Yes. Okay, so derivative 2x equals e to the y prime.
Yes.
So then what's y prime equal? 2x over e to the y. Okay, now when you do the second derivative, what are you going to have to use? Quotient rule. Correct. Please quotient rule that. Okay, don't simplify anything yet. Okay, because this has got a little bit of shortcut involved. So just quotient rule and then stop.
Should we immediately make our y primes what they're supposed to be?
No, I wouldn't yet.
Okay.
Yo. Yo.
This is
I'm just
almost
really
not
slow because I
that.
was making a mistake. So if it goes slow.
I did. Okay, so now listen. Well, let's put our y primes in, but we're not going to simplify. So 2 e to the y minus 2x, just a second, David. E to the y times 2x over e to the y over e to the 2y. Now, it looks like, oh my gosh, I got a double stack fraction, but look at this term. You've got an e to the y on the top and an e to the y on the bottom. Okay? No, that part is 1. But listen, here's the good news. All you want to know is that whether this is positive or negative, so you don't have to simplify anything because you're just plugging your numbers in. So you don't have to get a really nice looking second derivative because you're just plugging the numbers in. So
Don't care that Jan confused.
did you say that? Who said that?
That was Garrett. He said was though. He said
Oh,
was.
yeah, it's because
You good
I
now?
had Y prime and I didn't plug it in yet.
Oh, yeah, I popped my right prime in there. Okay, so also e to the y, e to the 0 power is what?
1.
So this is 1. That's 2 times negative 2 times 1 times 2 negative 2. 1.
Why did there are 2 negative signs there? 2 times negative 2?
Because x is negative 2?
Oh.
No,
Am I tweaking?
Nope.
quite possibly. This is 2 times 2 times 2 times 2, which is 16.
Wait, is this
I don't
zero
know,
or
I don't
one
think
that
you
you were
want.
plugging in?
As I just didn't yet.
Was this 0 or 1 that we're plugging in?
You're plugging in x is 2 and y is 0. So I'm plugging my e to the 0 in and just writing down 1 when it would be e to the 0, Lily. That's why.
This would also be no.
I would assume.
Negative
2, 4, 6, 8. 4, 8, 12. 4, 8, 16 over 1. It's negative 14. So, I mean, I get excited when I'm at a number. I'm like, I'm done. I'm not done because I didn't answer the question. Concave up or concave down?
Down.
Concave down. Because the second derivative, so y double prime is negative at the point -2, 0. Okay.
So glad we don't really simplify that.
I know, me too. Okay. I would like us to, yes, sir.
I just want to ask, so can we write negative, do we write out three letters, or do we have to write out the full word negative? Can you, on the AP test?
No, I would abbreviate it if it was me.
As an extension, can you abbreviate any words on the AP test, or should you write everything out full?
For safety, you should probably write it.
You should probably write it out.
Like, can you do the
I feel like you can. I've seen that. That's fine.
and it's okay.
Yep.
As long as it's clear what you.
You gotta make sure that somebody knows what you're talking about.
I'm gonna start using like slang and.
Yep.
Yeah, because it's very they're very precise in what you
Hey,
ask
bro.
grammatically,
Hey,
but
bro.
it's
You know
out.
what I'm talking about.
I use my couch.
Okay. So this is actually a SAT question or SAT. Oh my gosh, an AP test question that I've seen before. We already did this derivative. This is the one that we did on Friday. Okay, so flip it over and look at your derivative. So in a case, we got that. We got what they got. 2x minus 5y over 5x plus 2y. So when they say show that that's true, your work just needs to end up exactly the same as that. So what we have, I'll rewrite what we had, okay? So minus 2x, wow, 5y equals 25. Okay, so we had 2x minus 2y prime minus 5xy minus 5xy prime equals 0. Here, there we go. I was going to say something's wrong. Here's where you would want to be careful. Let's say that you, what do we do? Just a second. I moved my y primes, but let's say you didn't move your y primes. Let's say you moved the other things and kept your y primes. So you had minus 2y prime minus 5xy prime equals 5y minus 2x. Pull out your y prime and you have negative 2y minus 5x. Then you divide and you get y prime equals 5y minus 2x over negative 2y minus 5x. Now, based on what I told you, are those the same? Let me ask my question. Based on what I told you, are those equivalent?
Yes.
Yes, because every one of those signs is opposite. However, we have not shown that those two things are equal. So what do you have to do? No,
We're gonna take an A out.
you got to take a negative out. You just would have to go the extra step and actually show like that you're dividing by -1 over -1, or that you factored out a negative. So then you would be like, oh, this is negative 5x plus 5y over 2x over 2y plus 5x. Still not exactly the same. So then you would have to be like, hey, that equals 2x minus 5y over 5x plus 2y. So you have to have it exactly the same.
Very technical.
Very. Okay. So when they say, although my thought is, I love this because I know the answer. Like, give me a question like this, because then I can be like, hey, I know how to do this, and I got to get it right. But it has to be exactly the same. So you can't stop where we had the other day, where we had on the bottom, we had our y in the front and our x on the bottom. I'd have to take it one more step so that they were equal. Mason.
Can we skip the middle step right there before we reorganize? Like, just go straight to the reorganized version?
Probably.
Taking out the negatives.
Yeah, he's skipping, like, he would skip this step and go to here.
Oh,
I feel like
we
it's
take out the
generally
negative,
pretty
let's
obvious
skip
what
the-
they want you to do. Would they ever switch it around
Oh, yeah,
just to make
Yep.
it?
for sure.
Is it fine just to not do it that way and do it the other way? And they're like, okay, we want
If-
this stuff on the bottom.
That's fine. That's fine. You can absolutely do some reverse engineering and be like, oh, but if you don't catch it, then that's okay. Now, here you go. Find the slope of the line tangent to the curve at each point on the curve when x is equal to 2. So first of all, it's been a while since we've done this. Slope of the line tangent to the curve is another way of saying what? Nope, neither of those.
Tangent line.
Thank you. What's true about what slopes of tangent lines are the same as what? Which is derivative. This is just another way of asking you for the derivative. I know. It's because there's 4,000 ways you can say it. Here's the problem. It's a mild problem. It says at each point on the curve when x equals 2. So what do I not have? I have the derivative, but I don't have any y values. So here's my question. If I have an x and I don't have a y, what do I have to do? I have to plug it into the original and solve for y. Okay, so we're going to do that. So this is, I'm plugging my 2 into the original. Okay, not to the derivative because that's not going to help me. I got to have a coordinate point. So 2 squared minus y squared minus 5 times 2y equals 25. So this is 4 minus y squared minus 10y equals 25. Now, you guys, sometimes people freak out, but you look at this and go, this is a quadratic. That's going to drive where you move the things. You're going to put them, I saw Caleb do this. You're moving them to the right so that your y squared is positive. Okay, because you want y squared to be positive in all your quadratics. Why? Because it's
Less steps.
if you don't do that, then you have to factor a negative out of the front of it anyway. I don't want to do that, so I'm doing this. So this is y squared plus 10y plus 21. Now, we're assuming this is a no calculator. I am assuming this because this is factorable. What's it factor to? So y plus 7, y plus 3. What are my two y values?
-7 and -3.
Now you have two coordinate points. You have 2, -7, and you have 2, -3. Now, we're not going to take the time to actually plug them in, but then you would plug them in. Okay, but that's how you find that. Question, Remington? Okay.
So you just plug those values into the derivative and then you get
Correct. Okay, flip it over. Our equation, we're just going to write it down one more time. Minus y squared minus 5xy equals 25. And our derivative was
5x minus 2 and
I think it's plus 2y. Okay, now, here you go. This is information, like this paper, I would not lose this paper because this is your notes for this section. Super important right here, okay? Super important. Horizontal tangent line, okay? Horizontal tangent line. This is notes over here. What has to be true about the slope?
1, 0.
0. Slope has to be equal to 0. Okay. We're asked about a vertical tangent line. Okay. Think about a vertical line. What's the slope have to be? I heard it. Undefined. So yeah, it's an infinite slope, but that means it's undefined. So listen, if we're dealing with something that is a fraction, which this is the only time I've seen this vertical tangent line business at all, a horizontal tangent line, the slope is 0. The top of the fraction is equal to 0. That's fraction with a C there. On a vertical tangent line, better. On a vertical tangent line, the bottom of the fraction equals 0. So, it's a little bit of voodoo math here, but we got this. Okay. If the bottom of the fraction has to equal 0, bottom of the slope, right? Here's my slope. That has to equal 0. So 5x plus 2y has to equal 0. Now, the question wants us to find an x value where that's true. Okay, but this is an equation. There's infinitely many answers where x plus 2y could be equal to 0. So what you have to do with this, we're going to actually solve for y. Okay, it's a little counterintuitive, but if you are looking for an x value in your answer, you want to solve for the other one. So we're going to solve for y. So I'm going to minus 5x and divide by 2. So y is equal to negative 5x over 2. So this is true that when negative 5x is equal to the y, 5 over 2x is equal to y, there will be a vertical tangent line. We just have to figure out where that is. So what we're going to do is plug this y into this equation.
So it's like substitution?
It's absolutely substitution. All we've done is create a system of equations. So we've got x squared minus negative 5x over 2 squared minus 5x times that nasty thing equals 25. Okay, so let me remind you, when you square a fraction, you square the top and the bottom. So what is that? 25x squared over 4. Okay, the inside of the fraction comes out positive, but there is a minus in our original equation. Okay, when you multiply this mess, what do you get? 25x squared over 2, and that equals 25. So this automatically is going to be a whole lot better than you think it is because everything's x squared on the left-hand side. Now, we've talked about this, and I saw some people do it recently. You have fractions there. How are you going to get rid of those fractions? By? I wouldn't multiply by 2. I'd multiply by 4 because you want to get rid of both of them. So we're going to multiply everything by 4.
Can we pull out the x first?
No, because you can't pull it out from this side. I promise this is going to go well for us. Okay, so this is 4x squared. This is going to be 4, but then divide by 4. So this is minus 25x squared. What's the next one? 50x squared. Multiply the top by 4, divide by 2. So 100 divided by 2. And this is 100. Do you see how that makes life so much nicer? Okay, now we got nice numbers. So what do we got? 29x squared equals 100. Now we can solve. Should we divide by 29? Why do we do what? What's your question?
You do it by 2.
Because you would still have 25 over 2. It would be 50 over 2 then. You could. So then that would be 25. Yeah. So you'd be fine. Okay. This one?
The one above it, the denominators.
Because this is over 1. So 1 times 2, and this one was 2 squared, which is 4. Okay, so x squared equals 100 over 29. Square root, and the answer is done. We're done. Because you don't have to simplify, right? We've talked about that. There's your positive x value where there's a vertical tangent line. So a little bit of weirdness in that you have to set this equal to 0 and it's not solvable, but you're creating a system of equations. Okay, I'll put that back just a second. Your homework is 2, 5, and 6. You're welcome. Just a second.
There's another 2.
Oh, I want you to do number 3 on the front. I lied, so there's 4 questions. This is, listen, this one is easy because you're given the second derivative. This is super easy. Okay, so
Yeah, what about Lone Star Club?
2, there, yeah,
I think a lot of us are off.
5, 6. 2, 5, 6, and 3 on the front.
Yeah, dude, once that online assignment hits.
Yeah, probably you are.
I think it's a good syllabus.
Good.
The concept was there, but my performance might not.
I thought I knew what I was doing, and then it turns out.
Oh, I was gonna put that back up. Yep. There you go. 2, 3 on the front. 3 on the front, and then 2, 5, 6.
I'm telling you, if they could send the two,
Like,
questions that we would have had actually moved out last week, like, I wouldn't have.
Yeah, they give it. Yeah, they really do. They give us the first prime and the.
Yeah, and they give you a second one. So keep reading. You also get second. So number 3 is really fast.
It's just a whole bunch of squares, so I know what that. Oh, wait, I got that one. Line is.
The graph looks like that.
Oh, it's just 0. It had to be 20.
And the first derivative,
Oh, yeah.
second derivative, then it would be a neither.
No, there's two parts of the second one. And one
Oh, got it. I got what you're saying. Yep.
one of them has an x, and x is 0.
that's basically favorite. I think you got. What were you gonna say, Penny? Because this is what makes it seem more.
That's exactly what I did.
I just have to
I see your own shadow of it.
Make false lock. I'm so proud of myself.
So you did 1, 5, and 6.
Got it.
I just did do it.
Yes.
That's-
Miss Douglas is gonna see it, she's gonna be like, that's beautiful.
At a time. That's fair.
Yes, essentially.
I think I even left you a note about how beautiful it was.
Oh, good.
This is such a beautiful graph. That's penmanship, artistship. I don't know what the word.
How about my craftsmanship?
Simon and Mason were like, man,
Bye,
that was
folks.
easy peasy.
David.
I was like, I thought it was hard.
Every time I think that it's easy peasy, I don't get a good score.
Okay, so here's the
talking
deal.
just about the specific beautiful graph.
You want me to move your seat, but where am I going to move you? People are going to kill you.
You're gonna kill me.
Yes, they are.
I sat in this assignment for an entire semester. You didn't kill me.
There was a space between you. So
No, there
you,
wasn't.
tomorrow, yes, there was. You think about it.
That wasn't the equivalent.
Where are you going to not irritate people? That's what I want you to go
I'm already
think about.
irritating people.
I know, but I don't need to increase anybody else's stress. So go away and tell me tomorrow. Like, seriously, go away. Go away.
Okay.
You can tell me tomorrow.
I think you're mistaken. There is nowhere that you can put me.
Miss Douglas, you know who I was thinking about the other day?
Then that seems like you need to work on you.
I was thinking about Clay.
Go away.
Clay Hudson the other day.
Oh, Clay Hudson. Mercy sakes.
It is lunchtime. Please.
It is.